2, we are given that the joint distribution of xy is equals to 1 divided by a times y to the power of 2 times x, and y is greater than 1. X is between 1 divided by y and y. So for the first part, we need to draw the non-zero definition region of the joint distribution of joint density of fxy. And as we know that x is between y and 1 divided by y, so x equals to y is this line, and this is x equals to y, and x equals to 1 divided by y is this line. This is so based on this formula and y greater than 1, we know that the density function, the non-zero definition of joint density of fxy should be this blue region. And for the problem 2, we need to find a such that fxy is a valid joint density function. Based on the property of density function, we will have the integral of 1 to infinity, because y is should be greater than 1, and the integral of from 1 divided by y to y, because x is restricted to this region, and the double interval area of fxy dx dy should be 1. And after calculation, we let me just rewrite this formula, and it should be, we take the y out of the integral first, and this should be 1. And after calculation, we got that 0.5 times negative a is equals to this, where we define w is equals to ln y. So here after calculation, we got that a is equals to 2. And we get our distribution function of a density function of fxy is equals to 0.5 times 1 divided by y to the power of 2 times x. And for the problem 3, we need to draw the marginal and density function of fx and fy, and we rewrite the joint density function of fxy as we calculated before. It's this formula, and we know that apply the formula, we know that the marginal density function of fy is equals to the integral of minus infinity to infinity. Here is from 1 divided by y to y, because x is bounded in this region. The integral of distribution function of density function of fxy, integral with respect to x, and we plug in the value, and we got the marginal density function of fy is equals to 1 divided by y to the power of 2 times ln y. And we should draw this. This is kind of hard to draw. First, y should be greater than 1, and it should be like this part. And for the marginal density function of fx, it is the integral of minus infinity to infinity of fxy in integral with respect to y, since y is from 1 to infinity. So here we change negative infinity to positive infinity to 1 to infinity. Here we just do a plug in the formula and do the integral. No, sorry. I just we need to find the marginal density function of fx. It should be the integral from minus infinity to positive infinity of fxy, and integral with respect to y. And recall that the region of this density function should be this region. So here we do the integral in by 2 parts. It is from 1 divided by x to infinity, which corresponding to this part. And it is for this part, it should be x to infinity. So this is from 1, x is from 1 to infinity, and this is from x is ranging from 0 to 1. And after the calculation, we get our answer is 0.5. 1x is from 0 to 1, and 1 divided by 2 times x to the power of 2. 1x is greater than 1. So we draw the marginal density function of f of x. It should be, here is 1, here 0.5. This is a straight line and gradually decrease. And for the last part, we need to verify that fx and fy are valid density function. To verify it, we just need to make sure the integral from minus infinity to positive infinity, or within the restriction of fxy, the integral should be 1. So here we rewrite the formula of the marginal density function we get before. For x is equals to 0.5, 1, x is from 0 to 1, and is 1 divided by 2 times x to the power of 2 when x is greater than 1. And we do the integral since x is from 0 to infinity. Because x is from 0 to infinity because x is bounded by y and 1 divided by y, and it is equals to 0.5 times 1 plus 0.5 is 1. So the marginal density function fx is a valid density function, and for the marginal density function of y, it is equals to this formula as we calculated before, and we take the integral from 1 to infinity since y is from 1 to infinity, and we do the integral. It should be this from infinity to 1, and after calculation we get it equals to 1. So fy is also a valid density function. This is for the problem 2.